Now see, the experiment number 4 is that the verification of Norton's theorem. Verification of Norton's theorem. So the statement of Norton's theorem is that any two terminals of the network, any two terminals of the network, it can be replaced by an equivalent current source in parallel with that of equivalent resistors. Okay, so this equivalent current source, it is called as Norton's current, and this equivalent resistor, that is parallel equivalent resistor, it is known as Norton's resistance Rn. Okay, so this is the statement. The procedure for finding procedure for finding a Norton's current and the Norton resistance. So finding a Norton resistance, it is same to that of Thevenins theorem, and finding a Norton's current, it is nothing but again it is a little bit similar, but just short circuit this terminal. Short circuit terminal A and B. After short circuiting terminal, represent the current IN and calculate the value of current IN. IN ची value calculate करायची. So this value it can be calculated, and this value it can be connected in parallel with that of equivalent resistor, that is Rn. Again this Rn it can be calculated as seen from terminal A and B, and if there are voltage source, just short circuit this voltage source. If there are current source, just open circuit the current source. Okay, so by applying this method or by applying this procedure, we just calculate the value of IN and Rn, and this value it can be verified with our simulated value. The value upon simulated value see verify करणार. If it is same, then we can call it as a verification, or it may be hence we verify the Norton's theorem. Okay, now see the circuit diagram is that circuit diagram, it is similar circuit diagram. Just we want to represent the value of voltage, resistor R1, resistor R2, resistor R3 and resistor Rn. Okay, and for this, hello, काय doubt आहे का? Hello. No doubt, no? Okay. Now see, see, just represent the value of current, represent the value. We will take a similar value, similar घ्यायच्या value का different घ्यायच्या, as your wish. कोणते value घ्यायच्या? Hello. सांगा व्हॅल्यू कोणते घ्यायच्या? आता थेव्हनिन साठी घेतलेले घ्यायच्या का दुसरे घ्यायच्या? Okay, we will take similar value. Now see, take the value is that Vs is equals to 50 volt. Then resistance of R1 is nothing but 10 ohm. Resistance of R2 it is nothing but 15 ohm. Resistance R3 it is nothing but 5 ohm, and RL is equals to 20 ohm. या value घेतलेले आहेत आपण. Now procedure is that just remove the load resistance. First step is that remove the load resistance. Load resistance remove kara. Across this terminal A and B, just short circuit this terminal A and B. A and B short circuit kara. Represent the current flowing from this is nothing but IN, or it is called as ISC. ISC किंवा IN त्याला short circuit current म्हणतो किंवा Norton's current म्हणतो. Okay. Now applying KVL, KCL, just calculate the value of this IN, that is short circuited current or Norton's current. Norton's current ची value calculate करायची. So this value जी काय value येईल ती लिहायची. Now next step is that short circuiting, if there are voltage source, short circuiting this voltage source short circuit करायचा. If we short circuit this voltage source and calculate the value of RTH, or it may be RN, त्यालाच RTH किंवा RN represent करू शकतो आपण. So RN ची value calculate करण्यासाठी by applying series parallel technique, that is series parallel reduction technique, or it may be star delta technique, you just calculate the value of RN. And then finally draw the network in the form of Norton's equivalent circuit, that is equivalent current source. It is in parallel with that of resistor, that is equivalent resistor Rn. And then across terminal A and B, A and B च्या across, that is terminal A and terminal B, represent the removed resistance RL. RL resistance remove kara, and by applying voltage division, current division rule, just calculate the value of current IL. IL ची व्हॅल्यू काय करायची, कॅल्क्युलेट करायची. ओके, हे लक्षात आलंय ना? हॅलो, हाँ, करा व्हॅल्यू कॅल्क्युलेट. So just apply KVL to that first one mesh. Assign the direction. Current flowing from this is nothing but I1. Current flowing from this is nothing but I2. So this IN is nothing but I2. जो काय करंट आपला I2 येईल तोच IN असेल. Okay, I2 जो असेल तोच IN असेल. Now apply KVL. So just apply KVL. Write the equation. Equation लिहा, KVL apply करा. So when we apply KVL to the first one mesh, so 50 volt voltage source minus resistance R1 is nothing but 10 into I1 minus 15 into I1 minus I2. I1 minus I2. Okay, it is equals to 0. Just simplify this. That is 50 minus 10 I1, 50 minus 10 I1 minus 15 I1 minus into minus plus 15 I2 plus 15 I2, it is equals to 0. Again shift this I1 I2, or take I1 common. Minus 10 minus 15 is nothing but minus 25. It can be shifted to the right hand side, so equation becomes 25 I1 minus 25 I1 minus 15 I2, right? It is equals to 50. So this is equation 1. This is equation 1. बरोबर आहे ना इक्वेशन? हॅलो हॅलो, राइट, हे करेक्ट आहे ना इक्वेशन? 25 I1 minus 15 I2 minus minus 15 I2, it is equals to 50. This is equation first. Now apply KVL to the top mesh second. Mesh second ला KVL apply केला, that is mesh second KVL. We apply KVL. Write the value of resistance R3, that is minus 5 I2 minus 5 I2 minus 15 I2 minus I1 minus 15 I2 minus I1. It is equals to 0. Just simplify this. Minus 5 I2 minus 5 I2 minus 15 I2 minus into minus plus 15 I1, it is equals to 0. Just rearrange this equation. Minus 5 I2 minus 15 I2, so it becomes minus 20 I2. So 15 I1 minus 20 I2, it is equals to 0. Okay, so this is equation second. Now calculate the value of current I1 and I2. I1 आणि I2 ची व्हॅल्यू सांगा मला. किती येईल? कॅल्शियम मध्ये सॉल्व करा आणि सांगा.
3.63.
3.63. I1 is equals to 3.63. That is I1. It is equals to 3.63 ampere, and I2
2.72.
2.72 ampere. So this I2, it is nothing but IN. I2 हाच IN आहे ना, बरोबर ना? So value of I2, it is nothing but IN. I2 ची व्हॅल्यू कॅल्क्युलेट केली. Similarly, we calculate the value of RTH or RN. RTH आणि RN ची व्हॅल्यू सेम येईल. किती आली होती VTH मध्ये मगाशी? It becomes 11, no? Same procedure, that is across terminal A and B, short circuit this voltage source and calculate the value of RTH. So value of RTH is nothing but RN. RN, it is equals to 11 ohm. Calculate करायची गरज आहे का? लिहू डायरेक्टली. हॅलो, IN ची व्हॅल्यू कॅल्क्युलेट केली आपण 2.72 एम्पियर. Value of RN is nothing but 11 ohm. So this value we want to verify in the simulation, or it may be in the simulated window. Simulation window मध्ये आपल्याला ती व्हॅल्यू चेक करायची. See here, कॅल्क्युलेशन मध्ये काय लिहायचंय तुम्हाला बघा. टेबल मध्ये ISH, RTH व्हॅल्यू and IN. IL we will calculate after that. Similarly, theoretical value लिहून घ्या, that is ISH, RTH आणि IL. IL पण calculate करा. Just draw the equivalent circuit. याचे equivalent circuit draw करा. That is equivalent circuit, one current source, that is IN in parallel with that of RN resistor, and again in parallel with that of load resistance. याच्या parallel मध्ये load resistance असेल. So it becomes 20, it becomes 11, आणि हा जो काय असेल तो 2.72. किती येते व्हॅल्यू? हॅलो, बघा किती येते? 2.72. याच्यामधून फ्लो होणारा करंट पाहिजे मला. सपोज करंट फ्लोइंग फ्रॉम दिस इज नथिंग बट I2. अप्लाय करंट डिव्हिजन रूल. टोटल करंट 2.72 into opposite resistance, that is 11, divided by sum of all the resistance is nothing but 31. किती येते? किती येते व्हॅल्यू?
.965.
0.965. Okay, so it becomes load current IL, it is equals to 0.965 ampere. So it can be represented in milliampere. So 0.965 milliampere. Okay, एवढी व्हॅल्यू येईल. Now we want to simulate this experiment. आपल्याला याचा आता सिम्युलेशन करायचंय. So see, I will go through the simulation window. First of all, I will clear this all. Okay. Okay, so I required 3 resistance. I have take another one resistor. Just first one resistor, it is nothing but value of this resistor, it is nothing but 10 ohm, pahila resistor. Then value of second resistor, that is R2, value of R2, it is nothing but 15 ohm. I will select. And then third one resistor, value of this resistor is nothing but 5 ohm. याची 5 ohm आहे. Just kilo ohm मध्ये झाली. Okay, just rotate this. हा rotate करतोय and connect here. Okay, बघा value R1 is equals to 10 ohm, R2 is equals to 15 ohm, and R3 is equals to 5 ohm. One of the voltage source is required. I have taken one voltage, that is voltage आपण किती घेतलेलं आहे? Set the value of voltage, it is nothing but 50 volt. 50 volt set केलं. Just do connection, positive terminal. Here it is, we consider one positive bus bar. Here it is, another one we consider negative bus bar. Positive terminal of this, it can be connected. It can be connected to this resistor. Connection बघा आपल्या diagram नुसार. Positive terminal of the voltage source, it can be connected to resistor. Then this resistor terminal, these are the common terminal, and this terminal and this one terminal. हे दोन terminal काय आहेत? Short circuit आहे. So just we will check the current flowing from this. So I will connect here current source, positive terminal, or just I will connect here one multimeter and check the current flowing from this. That means the multimeter ने जर current measure करत असेल तर तो short circuit आहे असं consider करायचं. Okay, कारण पॅरलल मध्ये कनेक्ट करतोय आपण, सिरीज मध्ये नाहीये. सिरीज मध्ये कनेक्ट केला तर करंट दाखवेल, पॅरलल मध्ये कनेक्ट केलं जस्ट शॉर्ट सर्किट टर्मिनलचं करंट मेजर करतो. ओके, सो दीज आर द कनेक्शन. नाउ I want to measure current. I will start simulation. See the result. What is the value of short circuited current? IN. Theoretical value
2.72.
2.72. Our value here, that is 2.73. So it is nothing but it is equal. So hence the IN it can be verified. Okay. So IN, that is short circuited current ahe. IN, it is verified by using this simulation software, that is Tinkercad. Okay, Tinkercad वरून आपण IN calculate केला. Now similarly for procedure for RTH किंवा RN साठी same procedure. Voltage source, it should be short circuited, it is nothing but 0 value, and measurement of this is nothing but resistance. We measure a resistor. Again start simulation. Value of resistor is nothing but 11 ohm. Okay, त्याची value 11 ohm. Now this current source, and it will be connected in parallel. So we will calculate the value of IL. Similarly त्याची value आपण IL ची value calculate करूया. Now we required only 2 resistors. I will delete one resistor. Just these 2 resistors are connected in parallel. These 2 resistors are connected in parallel, and one of the current source is applied here. So value of first one resistor RTH ची value किती आले? RN ची 11. Just select this value 11 ohm. Value of RL is nothing but 20 ohm, and we want to measure the current flowing from this. याच्यामधून flow होणारा current check करायचा आपल्याला. Okay, so just I will connect one of the current source, that is measurement of current. See the value. हॅलो, बघा कनेक्शन काय केलेलं आहे मी. हा व्होल्टेज सोर्स करंट सोर्स आहे, त्याच्यामध्ये करंट सोर्स आपली व्हॅल्यू ऑफ करंट सोर्स दॅट इज 2.72, दॅट मीन्स IN. It is connected, and one of the parallel resistor, that is RTH or RN, it can be connected in parallel, that is 11 ohm. Then 20 ohm resistor, that is load resistance, and I want to check the current flowing from this resistor. या resistor मधला current किती flow होतोय मला check करायचं. So that means I have connected one of the ammeter in series with that of या पॉइंट पासून या पॉइंट पर्यंत मी सिरीज मध्ये ammeter कनेक्ट केले. ओके, म्हणजे इकडे फ्लो होणारा करंट मला किती आहे ते शो करेल. ओके. नाव when we start simulation, result it can be shown, that is 965 milliampere. So answer is that 965 milliampere. That means load current or current flowing from this is nothing but 965 milliampere. What is our theoretical or it may be calculated value? Calculated value किती होती? Hello. What is the calculated? 965 milliampere or 0.965. Okay. So hence the verification can be done. That is, hence we verify the Norton's theorem and calculated the value of load current. Okay. Getting? लक्षात आलं का?
Yes, sir.
Okay. Is there any doubt? Hello. Is there any doubt?
No.
Okay. If you want to check by using another value, that means if we want to check by changing the value, you can check, but result remains same. That means you verify. आपण जर एखादा प्रॉब्लेम सॉल्व केला असेल तुमच्याकडं, फक्त कनेक्शन मध्ये चूक करू नका. इफ यू हॅव डन कनेक्शन करेक्टली, देन युअर आन्सर शुड बी सेम ॲज आवर सॉल्व प्रॉब्लेम. आपला जो काय सॉल्व केलेला प्रॉब्लेम आहे त्याच्यासारखं सेम आन्सर असेल. कुठलाही एखादा प्रॉब्लेम घ्या and practice this. So if any doubt or if any problem for connection, then ask. Okay. So hence we will conclude this today's practical and we will stop here. Thank you.